This is Geometry 4.1, Triangle Sum Theorem, day number 2. What we're going to look at today is how this exterior angle is going to add up to equal these two angles right in here. The exterior angle equals the non-adjacent interior angles. What we see is we have a triangle, ABC. We want to show that this exterior angle is going to equal the two angles on the inside of the triangle that are not next to that one. If all three of these angles add up to 180, all the interior angles of a triangle add up to 180, and the linear pair adds up to 180, then A and B have to add up to equal 1. So we're going to try this out. So our given information. Now in this case they're not saying that ABC are given as our first step. They're kind of jumping to the conclusion. If a linear pair, then the angles are supplementary. Here we have a linear pair that they're supplementary. So angle 1 and the angle right here, the one that it's next to, are supplementary. So angle ACB, that's the angle right next to angle 1, comma angle 1, the one on the outside called the exterior angle, are supplementary. Let's take a look at that one more time. Here it says if a linear pair. Well, we see we have a linear pair. It's in the picture. We have our linear pair, then the angles are supplementary. Then means we're talking about it right now. We have to talk about that. We have to write that out right here. So that helps me know how to set up my proof, looking at my if-then statement. If has to come earlier, then is happening right now. Now I had to put in an extra line in here. If supplementary angles, we know those two angles are supplementary. If comes earlier, then the sum is 180. We have to talk about how those two angles add up to 180 degrees. The measurement of angle ACB plus the measurement of angle 1 is going to be 180 degrees. Because it's supplementary, the two angles add up to 180. Now, how do I know that these angles add up to 180? Can you find out where these angles are located? You got to use your eyes. We have angle A, angle B, angle ACB, which is right here. It's that interior angle. We've kind of been talking about that already. So why do those angles add up to 180? Because it's a triangle, we know that the interior angles add up to 180. If triangle, if we're given a triangle, or since we're given a triangle, but we like to start with if triangle, then sum of angles equals 180. Then the sum of the interior angles is 180. That's what we're saying right there. Then we're saying it. So you need to be sure your if comes earlier, then is happening right now. So what's our substitution? What do you see that is kind of related to each other? angle ACB, and the measure of angle 1 equals 180. The measure of A, the measure of angle B, the measure of angle ACB equals 180. We know that those two angles equal 180. The measure of angle ACB plus the measure of angle 1. And we also know that the measurement of angle A plus the measurement of B plus the measurement of angle ACB equals 180. So if two different groups equal 180, then those two different groups equal each other. So what do we notice? We want to get to the measure of angle 1 equals the measure of angle B plus the measure of angle A. Okay, I have my A and my B here. I have my angle 1 there. They're on the correct side of the equal sign. That's all good. What's my extra part? Why is that there? Why isn't it here? What am I going to do to make that go away so I can have just the 1, then the equal, then the A, then the B? What's that called? Subtraction property of equality. We subtracted the same angle from both sides of the equal sign. So when you subtract the same thing from both sides of an equal sign, you're left with everything else. That's called the subtraction property of equality. You do it most every day, every time you put together an equation. So what we just discussed was called the exterior angle theorem. Listen to those words, the exterior angle theorem. The exterior angle equals the non-adjacent interior angles. The two non-adjacent interior angles. They're called non-adjacent because we're not talking about the one right next to it. Angle 1 does not equal the one next to it. It equals with the two other interior angles. The non-adjacent interior angles. Every single time. Any triangle you make, if you extend the side, that exterior angle is going to equal those two over here. So we're going to use that fact to answer these questions. Look at the information they give us. The first thing people want to say is, ooh, we have a triangle. We must have 180. But we don't have that interior angle. We don't have that third inside angle. We have this exterior angle. What did we learn about the exterior angle? It equals the angles on the outside. So the measurement of angle DCB is going to equal the measurement of angle B plus the measure of angle A. So DCB is 3x minus 9. Angle B is 73. Angle A is x. So I substituted in all my values. Then you add your values across. We can subtract the x. And we divide by 2. And we get 41. Can you write that out without just copying it? Can you understand what we did? And then, oh, okay, I can follow that. I understand what's going on, and do your own math from there. Then they want us to know what the measurement of DCB is. The measurement of angle DCB is going to equal 3 times 41 minus 9 more. That's 123 minus 9. That's 114 degrees. That's the answer we're actually looking for, not the 41. That's X. We want to know what the measurement of DCB is. Okay, we slide down to the next one. What do you see when you look at this figure? There's something that should kind of jump out at you. What's kind of different about this picture? What do you see about this picture? We see the 2 arrows, which tells us the lines are parallel. Well, if lines are parallel, we're supposed to be looking for this. Which one of those do you see? Every time you see parallel lines, this is what you're supposed to think of. So which one of those do you see? If you go down the parallel line, and you go down the parallel line, we have 2 choices. We can either connect the parallel lines this way, and that will make y and this angle in the corner the same, but I don't have a name in this side of the corner. Or we can make our transversal go this way, connect the 2 lines that way. So my 43 is going to equal the angle in this corner. Hey, if parallel lines, then alternate interior angles are congruent. That means X is going to equal 43 degrees. That's why X equals 43 degrees. The more times you can write that, be familiar with that statement, the more you'll be ready to use it. Okay, so that is X. Now we need to find the other angle. Anyone have a suggestion on what we would do? How do we find Y? The math's not difficult. If I told you what to do, you could all solve for it. But the decision making on why do we set up our equation or a problem like this? What are we going to do to solve for Y? So if we come up and think about what we've learned before, it's called the exterior angle theorem. The exterior angle is going to be equal to those 2 angles. Angle 1 is going to equal the measurement of angle A plus the measurement of angle B. That angle here equals those 2 way out there. So down here, we're going to see a triangle. We extend that side, and 75 is called the exterior angle. So the exterior angle theorem is going to say that the exterior angle equals the non-adjacent, not the one next to it, but the non-adjacent interior angles. You could have talked about how next to the 75 was 105 and the 3 angles add up to 180. You could have done that. This is one step shorter. So this is telling us that y equals 32 degrees. You got to be observant to what you have. It doesn't quite work over here. Once you figured out this was 43 and that was y, then you're pretty much working with the same triangles, just in a different spot. All right, let's slide on down here. We have a right triangle. That's what our picture tells us. We want to show that angle A and angle B are complementary. Well, first of all, vocabulary. Do you know what complementary means? The measure of A and the measure of B are going to add up to 90 degrees. Do you agree with that? Doesn't all three angles add up to 180? And you take away the 90, that means the other two angles add up to 90. 90 for those two and 90 for this one makes 180. So if you have a right angle, the other two angles, I don't know what they are. They could be 30 and 60. They could be 20 and 70, 10 and 80, 45 and 45. That would be the big dream if it was isosceles. So if I know I have 180 and I take away my 90, then I'm left with 90. So if I'm going to show they're complementary, I have to first show that they add up to 90 degrees. So I bet that this row right here is going to be 90 degrees. I'm going to subtract that across to get my 90 degrees. That means my interior angles is 180. Okay, I got that. See, you can work on your triangle. You can work your proof by checking out the lines. So we have a right triangle. A right triangle tells us we have a right angle. It doesn't say it, but it implies it. So angle C, and I know that from the picture, angle C must be a right angle. Angle C is a right angle. If right triangle, then right angle. If you have a right triangle, you're guaranteed to have a right angle. Now look at what it's talking about. If right angle, if has to come earlier. If right angle, then we're going to talk about 90 degrees. So what are we going to put into this line that talks about 90 degrees? It tells you what to write. What are we going to say about 90 degrees? What's 90 degrees? The measurement of angle C equals 90 degrees. Now we know what C equals specifically. We knew it was a right angle because we knew we had a right triangle. If we have a triangle, then the interior angles will add up to 180. Then is happening right now. So what are we going to write over here if we know that the interior angles add up to 180? What are we going to write in this blank? You got to put your proofs together yourself. Look at the hints. They're telling you exactly what to say. The interior angles, what are they? They add up to 180. What are we going to write over here? The measurement of angle A plus the measurement of angle B plus the measurement of angle C adds up to 180. That's exactly what this is saying. The interior angles have a sum of 180. So we wrote down the interior angles and we equal it to 180. So where does this next line come from? What's different from where you started to where you are now? The A is the same, the B is the same. Where did this 90 come from? How do I know that? Substitution, property of equality. We knew that angle C was 90 degrees, so we substituted the 90 in place of the C, so we no longer have C. We don't want C in the end. We need to get rid of that. All right, what do we need to do from here? What's my goal? I'm trying to say that they're complementary. To say they're complementary, I have to say two angles add to 90. How am I going to get that? Subtract the 90 from both sides. Tells us that the measurement of angle A plus the measurement of angle B equals 90. I subtracted it. Subtraction property of equality. Okay, if what, then what? If 90 degrees, if two angles add to 90 degrees, that would be excellent if you added those extra words. But if we have 90, then complementary. It'd be even better if you would say if two angles have a sum of 90, then they are complementary. That would be great. This would be like the smallest possible. If you have 90, then you have complementary. All right. On the flip, we're talking about, this is corollary. Corollary to the triangle sum theorem. The acute angles of a right triangle. Here's your right triangle. What do you know about those acute angles? Those smaller angles are going to be what for every single right triangle possible? They're going to equal up to 90. That's just what we were talking about over here. That A and B add up to 90. The acute angles add up to 90. That they are complementary. That their sum adds up to 90 degrees. So, we can use that fact. Some people talk about, well, isn't there another way I could have done it? Well, of course there is. There's option number 1, and there's option number 2. Let's take a look to solve this. I know that angle A, the measurement of angle A, equals 22 degrees. I'm supposed to find this missing angle. Some people might say that the measurement of angle A plus the measurement of angle B plus the measurement of angle C adds up to 180. Because that's what a triangle adds up to. I know that angle A is 22 degrees. I know that angle C was my right angle, which is 90 degrees. So if I subtract my 90, (180 minus 90 gives me 90. That's kind of funny. But 180 minus 90 gives me 90. Then I subtract my 22, and the measure of angle B is 68. So that's one way you could have done it. You get the right answer. You showed all your work. Did a great job. What we're trying to point out, we're looking for the least amount of steps possible. So, I know this is a right triangle. I don't even have to deal with this 90. I can say that the measurement of angle A plus the measurement of angle B equals 90. And that's 22. So it's a teeny bit different. It has less steps. It has the same answer. Either way you do it. So whichever method that you realize, what do you recognize? All right, last one. This is a bit of a puzzle. What are we going to do to figure out the value of y? I think we'll find out y first. Then we can figure out x. Do you see something? Take a look at it. It's easy to copy me, but what are you going to do to help yourself find that? Think about the rules we talked about today. So we're going to look at this. If we look at y first, you see this triangle in there with an exterior angle. Now what was tricky about this exterior angle is it was exterior to this green triangle, but it's actually inside the big triangle. It's still considered an exterior angle to the green one. So using the exterior angle theorem, 85 is going to equal y plus 25. So y is going to equal 60 degrees. Then we have our other triangle. If we have 90 degrees here, we're going to have 90 degrees on the other side. So you know your acute angles are going to be complementary. Y equals 60 plus the x has to be complementary because the blue triangle is a right triangle. So that makes x 30.